If you work with AVR microcontrollers, there is a good chance you have used a USBasp programmer at some point. It is cheap, simple, widely available, and supported by a huge number of classic AVR devices. But the software experience around it is often scattered between command-line tools, old utilities, or large development environments. FlyingBytesPro was created to make that workflow more focused. FlyingBytesPro is a desktop application built specifically around USBasp programming. Its goal is simple: give you direct control over an AVR microcontroller while making the important information visible instead of hiding everything behind a single program button. At the center of the program is MCU detection. When a target is connected, FlyingBytesPro can read the device signature and match it against its built-in database. The current database contains 175 AVR devices. That includes 167 classic SPI ISP devices, plus 8 TPI devices such as the T-Tiny4, a T-Tiny5, a T-Tiny9, a T-Tiny10, a T-Tiny20, a T-Tiny40, a T-Tiny102, and a T-Tiny104. For devices that share the same signature, the program uses a logical default. For example, if a standard device and it's a variant use the same signature, automatic detection prefers the standard model, while the variant still remains available in the MCU dropdown for manual selection. The MCU list itself is also organized so related devices stay together. Smaller families come before larger ones, and closely related variants are grouped in a way that makes sense when you are looking through the list. Once a device is selected or detected, you can work directly with flash memory, EEPROM, fuses, and lock bits. The flash and EEPROM tabs are not just simple file loaders. They include an editable hexadecimal memory view, decimal addresses, and an ASCII representation. You can inspect data, modify bytes manually, clear selected regions, zero memory, load Intel hex files or raw binary files, and save memory back out again. Verification is built into the workflow. After programming, FlyingBytesPro can read the target back and compare the result against the data you intended to write. Flash and EEPROM verification only needs to read through the highest defined address in the loaded firmware image, which avoids wasting time reading unused memory when it is not necessary. Fuse and lock bit programming is handled separately because these bytes can change how the microcontroller behaves at a very fundamental level. FlyingBytesPro reads the existing values internally, preserves reserved bits, applies the writable mask, writes the requested value, and verifies the result by reading it back. That means the application is doing more than simply sending a raw byte and hoping for the best. Clock speed is another important part of AVR programming. If the programming clock is too fast for the target, communication may fail. FlyingBytesPro provides fixed SCK selections in automatic scan mode and a pro mode that uses the USBasp firmware default. Auto mode starts from the fastest supported rate and works downward until the target responds successfully. This is useful when you do not know the clock state of the microcontroller you are connecting to. For repeat work, the Task tab allows several operations to be combined into an automatic programming sequence. A typical workflow can confirm the signature, erase the chip, program flash, program EEPROM, verify memory, write fuses, and finally write lock bits. This is useful when programming several boards with the same firmware and configuration. Projects can also be saved. A project file can store the selected MCU, firmware data, EEPROM data, task choices, and programming settings. That makes it possible to reopen a programming job later without rebuilding the setup from scratch. The application keeps detailed logs as well. The normal interface gives you compact status information, while the full log provides the lower-level details needed when diagnosing USB, ISP, TPI verification, or device communication problems. FlyingBytesPro also includes a command-line interface. So if you prefer automation, scripts, batch files, or terminal-based programming, the same project includes a direct USBasp CLI with AVRdude-style memory operations. You can read, write, verify, erase, select SCK speed, detect devices, list supported parts, and perform repeated operations from the command line. The interface supports multiple display languages. English is the default, with simplified Chinese, Spanish, Japanese, German, Korean, French, and Vietnamese also available. These language packs only change the text shown in the graphical interface. The actual programming logic, protocol values, project data, device identifiers, and internal behavior remain unchanged. That distinction is important because FlyingBytesPro is intended to be predictable. Changing the interface language does not change how a fuse is written, how a USBasp command is sent, or how a firmware image is interpreted. The overall idea behind FlyingBytesPro is to combine the control of a low-level programmer with the convenience of a modern graphical interface. It is not trying to replace a full embedded development environment. It is focused on one job, communicating with AVR devices through USBasp and giving you clear control over what is being read, written, verified, and configured. So whether you are programming a fresh microcontroller, repairing an old board, experimenting with fuse settings, working with TPI devices, or simply looking for a cleaner USBasp workflow, FlyingBytesPro is designed to make that process easier to see and easier to control. If that sounds useful for your AVR work, this is FlyingBytesPro.